Aloha, here's some fraction exploration, part number 3. All right, today we're going to dig deep into fractions and expand, watching a video lesson about improper fractions. And today we're looking at how we're going to express improper fraction as mixed numbers.
Mathematicians, in this lesson, you will learn how to express improper fractions as mixed numbers using pictures and division. This is another step in connecting fractions with division. You already know that mixed numbers and improper fractions are fractions that represent values between two whole numbers other than 0 and 1. You also know that mixed numbers and improper fractions are two ways to show the same value, they just look a little bit different. So remember that this picture represents the mixed number 2 and 4/5 because there are two whole rectangles shaded in, and 1, 2, 3, 4 out of 5 pieces in one single hole in the last rectangle. But it also represents the improper fraction 14/5 because I have 5 pieces from the first rectangle, 5 pieces from the second rectangle giving me 10, and 11, 12, 13, 14 from the last rectangle giving me 14 total pieces shaded when there are 5 pieces to make one whole. Today we'll use our knowledge of the relationship between mixed numbers and improper fractions to express an improper fraction as a mixed number. I'm going to show you how to do this by using the fractions 8/4 and 9/4. Let's start with 8/4. I know that this is an improper fraction because the numerator is larger than the denominator, which means that the value is greater than 1. One way to express this as a mixed number is to think about what 8/4 looks like as a picture. I know that each object should be split into 4 evenly sized pieces to make a whole because of the 4 in my denominator, and that I want to consider 8 pieces. When I draw my first hole, I realize that I can only shade in 4 pieces before I've shaded in the entire thing, so I need to draw a second hole in order to get to the 8 pieces I want to consider. When shading in the pieces in my second hole, I count that I have 4 from my first and 4 from my second, giving me 8/4 total. So this picture shows me 8/4 as an improper fraction. And looking at it, I see that there are 1, 2 whole squares shaded in, meaning that 8/4 is equal to the mixed number 2 with no remaining fraction left over, or 8/4 is just equal to 2. My really observant mathematicians out there might have noticed that 8 divided by 4 is also equal to 2, so that I might say that 8/4 is equal to 8 divided by 4 is equal to 2. Now let's look at 9/4, another improper fraction. Here, when I draw my first 2 squares and get 4 in each square because of my denominator of 4, I realize that I only am able to shade in 8. That means that I need to draw another square to get to the 9 pieces that I want to describe. And I just need to shade in 1 remaining piece to get to a total of 4, 8, 9 pieces that I'm looking for. This picture then shows me that the mixed number equivalent to 9/4 is 1, 2 holes and 1 out of 4 pieces in a hole. So 9/4 is equivalent to 2 and 1/4. Again, my observant mathematicians might see here that 9/4 equals 2 and 1/4, and that 9 divided by 4 is equal to 2 with a remainder of 1, or in this case, a remainder of 1 out of the 4 pieces in one whole. You are probably beginning to see the connection between fractions and division from the first 2 examples. But let's do one real-world example just to make sure we really understand. Pizzas at a party are split into 6 pieces. At the party, 18 pieces are eaten. How much pizza was eaten at the party? I see from my problem that 18/6 of a pizza is eaten because each pizza is split into 6 pieces and 18 pieces are eaten. 18/6 doesn't make a lot of sense to me, though, because it's an improper fraction and doesn't tell me how many pizzas we ate at the party, so I want to turn it into a mixed number. Drawing a picture, I see that 1 pizza is not enough because it only gives me 6 pieces, and I'm really looking for 18. That means I need to keep drawing pizzas to get to the 18 pieces I need. A second pizza of 6 pieces gives me 12 total because 6 from the first and 6 from the second equal 12, and this is still not enough, so I need to draw a third pizza. When I look at the third pizza, I see that I have 6 from the first, 6 from the second giving me 12, and 6 from the third, which gives me the 18 pieces that I'm looking for. And from my picture of 18/6, I can see that really we ate 3 total pieces. Once again, I can see that there's a relationship between fractions and division because 18/6 is equal to 18 divided by 6, which is equal to 3. From today's lesson, you learned that improper fractions can be expressed as mixed numbers, and you learned how to do this in two ways. First, you learned that you can draw a picture to show the relationship. Second, you also learned that you can divide your improper fraction. You should be continuing to connect fractions to division from this lesson.
Awesome. Thank you to our friends again at Learn Zillion. It's an awesome website with amazing mini lessons. Now, for today's exploration, I clipped in an awesome dice game that you can play. You can play with your. It says you need two players, but if you are alone, you could maybe fold a paper in half and assume the role of both player number 1 and player number 2. And you will need dice. If you do not have dice, I've seen this really cool, innovative student use a pencil as a hack. And on the pencil, there were 6 sides to that. And he labeled each side with a number, and he rolled his pencil to problem solve. Okay, for those of you with online access and who has the slide deck available, you can click here to get the dice. It's going to take us to a site called Toy Theater. And what you're going to do is you're going to choose the type of dice you want to work with. I'm just going to choose a standard. We only need one. And each time you throw the die, you can put down and use this to help you play the game. All right, so it's directions. Player A rolls one number cube. The number rolled becomes the denominator for both players. Okay, for in this example down here, it's showing us that on the first roll, player A rolled a 4. So both players put the number 4 down in their denominator. Okay, as their denominator. Okay, after you get that first roll, players A and B then each roll a number cube to fill in their numerators. All right, after all numerators are filled in, add up the fractions to create an improper fraction. And between the two players now with your improper fraction, players A and B will convert their improper fractions to mixed numbers and check each other's work. All right, again, if you're by yourself, you can just do a double check on each side, and the player with the larger mixed number gets a point. So again, the player with the larger mixed number gets a point. Have fun playing with dice and practicing your fraction addition and conversions from a mixed number from an improper fraction to mixed number. Have fun. Thanks for watching.